Mr. Wright here, and welcome to this film, which is me going through all the questions in the mixed exercise at the end of Chapter 5, the straight line graphs chapter. If you find this film useful, please do tell me so by hitting like. If you've got any questions, please leave them in the comments, and I'll respond or comment anyway, by all means. And if you found this film useful and you'd like to be notified when I release similar films, please do subscribe to the channel. Right, let's get on with the maths. Question 1. Right, we have to find the equation of a straight line. It passes through the point P, and it has a gradient of minus 5/12. So y minus y1 equals the gradient multiplied by x minus x1. Multiply everything by 12. 12y minus 12 equals minus 5x minus 2. 12y minus 12 equals minus 5x plus 10. So 12y plus 5x, adding x, 5x to both sides, equals 22. There's part A. And part B, I need to determine the value of k. Well, I know that the point K11 is on the line. So I know that when y equals 11, I need to find out what x equals. Well, here's the equation of the line. Y equals 11, then 22 plus 5x is 22, which gives me an x of 0. So the point is 0, 11, and k equals 0. That's number 1 sorted. Question 2. I have the point A, which is k1, and the point B, which is 8, 2k minus 1. And I know that the gradient is a third, and I'm asked to find the value of k, or show that k is minus 2. So I'm going to start off by setting up an equation. The gradient a third is the rise over the run. So I'm going to do the difference in the y coordinates, b take away a. So that's going to be 2k minus 1, take away 1. And the difference in the x coordinates, again, b take away a. Right, let's simplify that. So a third is going to equal 2k minus 2 over 8 minus k. Multiply both sides by 3. 1 equals 6k minus 6 over 8 minus k. Multiply both sides by 8 minus k. 8 minus k equals 6k minus 6. Add k to both sides and add 6 to both sides. Shows me that k equals 2. Good. Okay, now I've got to find the equation of the line. Well, I know that point A, which is on the line, is now going to be 2, 1, and I know the gradient is a third. So I'm going to use y minus y1 equals the gradient multiplied by x minus x1. Multiply everything by 3. Let's add x to both. Oh, let's put it in terms. Let's make it into y as the subject for a change. So y is going to be x over 3 plus 1/3. And that is question 2 sorted. Question 3. Right, I've got to find the equation for the line L1 and the equation for the line L2. Well, L1 has a gradient of a seventh and passes through the point A, and L2 has a gradient of minus 1 and passes through the point B. So looking at L1, y minus y1 equals the gradient multiplied by x minus x1. Let's simplify that. 7y minus 14 equals x minus 2. So let's write that as 7y minus x equals 12. And let's do the similar thing for L2. Y minus 8 equals minus 1 multiplied by x minus 4. Y minus 8 equals minus x minus plus 4, I beg your pardon. So I'm going to have, let's write this in the form y equals. I'm going to have y equals minus x plus 12. So there's an equation for L1 and an equation for L2. Part B, determine the coordinates of C. Well, that's the point of intersection, isn't it? So I'm going to solve these two equations simultaneously. So I'll write them down. And I'm going to solve this by substitution. I'm going to substitute equation 2 into equation 1. So now I'm going to have not 7y, but 7 lots of minus x plus 12. Minus x equals 12. So that's going to be minus 7x plus 84 minus x equals 12. So I'm going to have minus 8x equals 12 minus 84, which is minus 72. Divide both sides by minus 8, x equals 9. And so what does y equal? Well, y equals minus x plus 12, which would be minus 9, plus 12, which would be 3. So my point of intersection is the point 9, 3. And that is question 3 sorted out. Question 4. Now for part A, I need to find the equation of a line which goes through point A and point B. To write down the equation of the line, I need to know its gradient. So I'm going to work out the gradient by doing the rise, the difference in the y coordinates over the difference in the x. I'm going to do b minus a. So the rise is 6 minus 0, and the run is 5 minus 1. So the gradient is 6 over 4, 1.5. Okay, so now I can use y minus y1. I'll use point A. Y minus 0 equals 1.5 x minus 1. Multiply both sides by 2. 2y equals 3x minus 3. So y is 3 over 2x minus 3 over 2. Okay. So I have found the equation of the line, and now I'm going to do part B. I'm going to determine the coordinates of C. I need to find the coordinates of C, which is where my line from part A, which is this line, intersects with this line, 2x plus 3y equals 15. Okay, so I'm going to substitute from equation 1 straight into equation 2. So I'm going to have 2x plus 3 lots of 3 over 2x minus 3 over 2 equals 15. Right, let's multiply out that bracket, shall we? 2x plus 9 over 2x minus 9 over 2 equals 15. Let's double everything. 4x plus 9x minus 9 equals 30. 13x equals 39, so x equals 3. And what about y? Well, let's use the first equation, which tells me that y is 3 over 2x minus 3 over 2. And if x is 3, then that is 3 over 2 times 3 minus 3 over 2, which is 9 halves minus 3 halves, which is 6 halves, which is 3. So my point of intersection is 3, 3. And that is question 4 sorted out. Question 5, I need to find an equation for the line which passes through the point A and passes through the point B. So first thing I'm going to need to know is the gradient, and I'm going to work that out as rise over run, doing the coordinates of B subtract the coordinates of A. So the rise is the difference in the y coordinates, and the run is the difference in the x coordinates. So that's going to give me minus 22 over minus 20, which is 22 over 20, which is 11 over 10. So that's the gradient of my line. And so now I'm going to use y minus y1, and I'll use the point A. Y minus 3 equals the gradient multiplied by x minus 1, which is going to give me 10y minus 30 equals 11x minus 11. And I need to give it in the form where I've got equals 0 here. So I'm going to have 10y minus 30, and I'm going to subtract 11x, and add 11. So that's going to give me 10y minus 11x minus 19 equals 0. And there is the equation of the line L. Question 6. Right, in part A, I have a line which goes through A, which is 2, 2, and B, which is a point 6, 0. And I need to find its equation. Well, I'll start by finding its gradient, rise over run, the coordinates of B minus the coordinates of A. Gives me minus 2 over 4, which of course is minus a half. So my gradient's minus a half, and it passes through the point A. So it's going to be y minus 2 equals minus a half x minus 2. Multiply both sides by 2. 2y minus 4 equals minus x plus 2, multiplying out that bracket. And so I'll give it in this form, 2y plus x equals 6. There we go. Part B. Now in part B, I've got a straight line L2, and it passes through this point, and it has a gradient of a quarter. So I can simply say y minus y1 equals the gradient multiplied by x minus x1. Notice that's x minus minus 9 there. It's going to be y equals 1 quarter of x plus 9 multiplied by 4. And I'll put it in the same form as before. 4y minus x equals 9. That is question number 6 complete. Question 7. I have a line which passes through the point A and through the point B. I need to find where this line meets the x-axis. So the first thing I'm going to do is I'm going to find the equation of this line. So I'm going to start by finding its gradient. So the gradient is the rise over run, so it's the difference between the y-coordinates over the difference between the x-coordinates. I'm going to do the y-coordinates and the x-coordinates of B, take away their counterpart in A. So the rise, the y-coordinate of B, subtract the y-coordinate of A, over the x-coordinate of B, subtract the x-coordinate of A. Let's simplify that. 3 plus root 3 over 1 plus root 3. Let's take that even further. Let's rationalize the denominator. It's bound to make things easier in the long run. So I'm going to multiply top and bottom by 1 minus root 3. Okay, so the numerator is going to become 3 times 1 is 3, minus 3 root 3 plus a root 3 minus 3. And the denominator of that is just 1 take away 3. So let's carry on simplifying that. On the numerator, the 3's disappear, and I'm left with minus 2 root 3 over minus 2, which is simply root 3. So that's the gradient. Right, I can write the equation now of my straight line L. The equation is going to be y minus y1. I'll use the point A. Y minus 3 root 3 is the gradient multiplied by x minus 1. Okay, which gives me y equals, let's multiply that out, root 3x minus root 3 plus 3 root 3, moving that over from the left-hand side, which means that y equals root 3 of x plus 2 root 3. Okay, now I'm asked to show that this line meets the x-axis at the point C, minus 2, 0. So if I substitute in x is minus 2, I'm hoping I'm going to get a y-coordinate of 0. So let's try that. X is minus 2. That will mean that y equals root 3 times minus 2 plus 2 root 3. And lo and behold, that is 0. So my line does go through the point minus 2, 0. And that is where the line crosses the x-axis. Question 8. So I have the point A and the point B. and a line is drawn through B perpendicular to AB. Let's first of all find the gradient of AB. So that's going to be the difference in the y coordinates over the difference in the x coordinates. Look out for that minus a minus. 2 over 6 is a third. So that's the gradient from A to B, and my line P is perpendicular to that. So the gradient of the line P is going to be the negative reciprocal of that, so it's minus 3. So I'm looking to write down the equation of the line which goes through B, so it goes through 2, 8, and it has a gradient of minus 3. Y minus y1 equals the gradient multiplied by x minus x1. So let's simplify that. Y minus 8 equals minus 3x plus 6. So y equals minus 3x plus 14. Okay, now this line P meets the y-axis at the point C, and I have to work out where that point is. So for part B, I want to know where this line meets the y-axis. So I'm going to put x equals 0 into the equation y equals minus 3x plus 14, which tells me that y equals 14. So the point C, where this line meets the y-axis, is the point 0, 14. And that's question 8 complete. Question 9. I have the line L, which has the equation 2x minus y minus 1 equals 0. And I have the line M, which passes through the point A, 0, 4, and is perpendicular to the line L. Well, the line L has an equation, if I take y onto the other side, y equals 2x minus 1. So it has a gradient of 2. So the line M, for part A, my line will have a gradient. The gradient of M is the negative reciprocal of 2, and it goes through the point A. So its equation is y minus 4 equals minus a half x minus 0. So that is y equals minus a half x plus 4. Right. So that's the equation of M. Part B, I have to show that the line M, which is this one, and the line L, which is this one, intersect at a certain point. So I'm going to find that point of intersection. So if I rearrange this one again to y equals 2x minus 1, I've got y equals minus a half x plus 4, and y equals 2x plus 1, 2x minus 1. So I'll set those two expressions equal to each other. That's plus half an x, 2.5 x, add 1 to both sides, equals 5. So x equals 2, and then let's use the equation y equals 2x minus 1. When x is 2, 2 times 2 minus 1 is 3. So they cross at the point 2, 3, which is the point P. So I've done that. Right, now part C. The line N passes through the point B and is parallel to the line M. So it shares a gradient with the line M. So its gradient is going to be minus a half. Right, so let's find this equation then. So I'm going to have y minus 0 equals minus a half x minus 3, which is going to tell me that y equals minus a half x plus 3 over 2. That's the equation of the line N, and I have to find the coordinates of the point of intersection between L and N. So I better write down the equation of the line L, which is this one, y equals 2x minus 1. So now I'm going to solve those simultaneously. Right, y equals this, y equals that, this equals that. Okay, I'm going to add half an x to both sides, 2.5x plus 1 to both sides equals 5 over 2. Divide by 2.5, x equals 1. And y will be 2 times x minus 1, which is 1. So the point of intersection between those two lines is the point 1, 1. And that is my solution for question 9. Question 10. Right, let's start by drawing a diagram. We've got the point A, which is at 0, minus 2. And we've got the point B at 6, 7, 2, 4, 6, 2, 4, 6, 7. There we go. There's the point B. And we've got the line L1, which passes between them. I'm not going to use a ruler. L1, right. Now I can see, really, just by inspection, that the equation of that line is y equals, now the gradient, the rise from A to B is 9, and the run is 6. So the gradient of that is 9 over 6, which I can simplify later. So the equation is 9 over 6x minus 2. So that's the equation of L1. And then it tells me about the line L2, which is x plus y equals 8. So L2 will go through here and here. Again, I'm not going to use a ruler. So that is L2, which is x plus y equals 8. And it tells me that the two lines intersect at D. And the line L2 cuts the y-axis at the point C. There we go. Right, and I'm asked to find the triangle of the area of triangle ACD. So I need to find the area of that triangle. Well, I can see that the base is 10, and I just need to really find the height. Now, in order to find the height of that triangle, I need to find the x-coordinate of point D. So I've got y equals 3 over 2, x minus 2, and I've got y equals 8 minus x if I rearrange the equation for L2. So I can solve those simultaneously. Y equals this and y equals that, so this equals that. Plus x to both sides, 5 over 2x equals 10. So divide both sides by 2.5, x is 4. So the x-coordinate at that point is 4. So I now know the height of my triangle is 4. So the area of the triangle is 10 times 4 divided by 2, 20. And that's my answer to question 10. Question 11. In part A, I need to find the equation for L1. And L1 passes through A, which is 216, and B, which is 12 minus 4. I better find the gradient of that, I guess. So the gradient is going to be the y-coordinate of B minus the y-coordinate of A over the x-coordinate of B minus the x-coordinate of A. So that's minus 20 over 10, so that's minus 2. So my equation is going to be y minus, I'll use A, y minus 16 equals minus 2, x minus 2. So y minus 16 equals minus 2x plus 4. I'm asked to put it in the form all the x's and y's on one side and all the numbers on the other. Here we go. Y plus 2x equals 20, or 2x plus y equals 20. That's my part A done. Right, part B, L2. Let's have a look at part B. L2 passes through C, which has those coordinates, and L2 has a gradient of a third, so it's simply a question of me going y minus the y-coordinate of C equals 1/3 x minus minus 1. So that's going to be y minus 1 equals 1/3 of x plus 1. Multiply both sides by 3. 3y minus 3 equals x plus 1. Does it say what form it wants it in? Find an equation, well, I'll put it in the same form as before, shall I? So I'll leave the positive x here, I'll minus 3y from both sides. Got minus 3 on the left, take away 1 is minus 4. So x minus 3y equals minus 4. And that's my equation for L2. And that is question 11 complete. Question 12. Right, let's start by drawing a diagram so we can understand what's going on here. We've got A at -1, -2. There we go, there's A. We've got B at 7, 2, 2, 4, 6, 7, 2. There's B. Okay, so here's the line AB. Right, C is at something 4. So C is got a y coordinate of 4, so it's somewhere along here. And I know that A, B to C is a right angle. So this is a right angle. So it's going to look something like that, isn't it, with a right angle? And C is going to be kind of there somewhere. All right, now let's see what the question asks us to do. Part A. Find the gradient of AB. Well, I've got A at -1, -2, and B at 7, 2. So the gradient of AB is going to be 2 minus minus 2 over 7 minus minus 1, which is 4 over 8, which is 1/2. Okay, calculate the value of K. Right, well I know that this point C, I know that B to C, that line is going to have a gradient of the negative reciprocal because BC is perpendicular with AB. So that's got a gradient of -2. Right? And that says calculate. I could just read it off my diagram, but the question asked me to calculate it. So I'm going to find the equation of the line BC. I know that it's great gradient there, and I know that the point B lies on the line. So I can simply go y minus 2 equals -2 x minus 7. Y minus 2 equals -2x plus 14. Y equals -2x plus 16. So I need to calculate the value of K. Now K is the point on that line where Y equals 4, because K is the point C is the point K4. So I need to put Y equals 4 into there and find my value of X. -16 from both sides gives me -12 equals -2x. So X equals 6. So the point is at 6, 4, and K equals 6. Let's go back to my diagram. So I know that that is 6, 4 there. Find the equation of the straight line passing through B and C. Well, I've done that. Okay, that is this equation here. So part C, find the equation of the straight line. It is y minus 2x, y equals -2x plus 16, and it wants to give it in the form of 2x plus y equals 16. No, it doesn't. It wants 2x plus y minus 16 equals 0. So that's part C done. Right, calculate the area of triangle ABC. Here's the area. Sorry, here's the triangle ABC. And I need to calculate its area. So I want to know the base and the height, and then I'll do base times height divided by 2. Right, well the base, let's do this over here. So the base runs from A to B. So that is from -1, -2 to B, which is 7, 2. So that distance from A to B, I'm going to use Pythagoras now and think about this right angle triangle here. So the difference in my x coordinates is 8. So AB is going to be the square root of 8 squared plus 4 squared, which is the square root of 64 plus 16, which is root 80. Okay, so that's AB. I also need to know CB, and CB is part of a right angle triangle that looks like this, doesn't it? 1 and 2. So CB is the square root of 2 squared plus 1 squared.
So CB is the square root of 5. So the area of my triangle is root 80 multiplied by root 5 over 2. So, presuming I need to work that out on my calculator. So that's going to be root 80 times root 5, which gives me 20, divided by 2 gives me 10. And of course it does, because 80 times 5 is 400, so that's root 400 on the top. Okay, that is question 12 finished. Question 13, part A, I need to find the equation of a straight line which goes through these 2 points. So I'm going to start by finding its gradient. Well, its gradient is minus 2 minus 5 over 4 minus 1, which is minus 7 over 5. So that's the gradient of the line. And so now I'm going to use this first coordinate, minus 1, 5. I'm going to write y minus y1 equals the gradient multiplied by x minus 1, x minus x1. So that's going to give me y minus 5 equals minus 7 over 5x plus 1. Multiply everything by 5. 5y minus 25 equals minus 7x minus 7. Multiplying out that bracket on the right. And it wants to have everything on the left. So I'm going to add 7x to both sides. Keep that 5y there. Add 7 to both sides. And there is the equation of the line in that form where a, b, and c are integers. Good. Okay, part B. Right, this line crosses the x-axis at point A and the y-axis at point B. Well, let's find those points, shall we? So the line we're dealing with, 7x plus 5y minus 18 equals 0. Let's see where it crosses the y-axis first. If x is 0, then 5y must be 18. So y must be 18 over 5, which is 3 3/5. So there's one of my points, 3 3/5. And if y equals 0, let's find out where this line crosses the x-axis. Then I would have 7x equals 18. So x would be 2 4/7. So here's the point where the line crosses that axis. Okay, so I've got to find the area of the triangle between the origin and those 2 points. Let's draw a quick sketch. There's the origin. So I've got 2 4/7 along there, and 3 3/5 along here, and I've got to find the area of that triangle. So the area of the triangle will be the base, 2 4/7, multiply the height by the height, divided by 2. So I'll do that on my calculator. 2 4/7 multiplied by 3.6 equals, divided by 2 equals, that gives me an answer of 4.63 to 2 significant figures. Sorry, to 2 decimal places. Question 14. Okay, I've got 2 straight lines, L1 and L2, and on the same axis I'm asked to sketch the graphs showing clearly all the coordinates of the points where the graphs meet the coordinate axes. Right, let's plot 4y plus x equals 0 first. Clearly goes through 0, 0. And if I take x of 8, 2, 4, 6, 8, then I will have a y of minus 2. There we go, there are 2 points on the line, and so I can join those. And there is the sketch of my line. 4y plus x equals 0. And I'm asked to label the points to make it clear the coordinates of the points where the lines cross the axis. So that's the point 0, 0. Right, let's do y equals 2x minus 3. The y-intercept is minus 3, and it has a gradient of 2. So here is my sketch of that line. There we go. And that is the line y equals 2x minus 3. And where does it cross the axes? Well, clearly this point here is 0, minus 3, the y-intercept. The x-intercept by inspection is going to be 3 over 2, 0. Okay, that's part A done. Right, part B calculates as exact fractions the coordinates of the point of intersection. Right, I've got this expression for y here, and I'm going to substitute that into the equation for L1, which is going to give me 4 lots of 2x minus 3 plus x equals 0. Let's multiply out the bracket. 8x minus 12 plus x equals 0. 9x equals 12. So x is 1 1/3, or 4 thirds. Now y, of course, is twice x minus 3, which gives me minus 1/3. So my coordinates of A are going to be 4 thirds, comma, minus 1/3. And there is the point A on my graph. Right. Point C. Find an equation of the line going through A. So that's great. I know a point on the line. I know it's going to go through the point A. And this line is also perpendicular to L1. Well, let's find the gradient of L1, and then we can find out the gradient of our line. And the equation of L1 is 4y plus x equals 0. If I rearrange that into y equals mx plus c, I can then just read off that the gradient of L1 is minus 1/4. Great. So the gradient of my line is the negative reciprocal of that, 4. So now I need to write down the equation of a line which has a gradient of 4 and goes through the point A. Okay, y minus y1 is my minus 1/3, so that's y plus 1/3 equals the gradient multiplied by x minus 4 thirds. Okay, let's multiply out that bracket first. That's 4x minus 4 fourths is 16 thirds. Let's multiply everything by 3. 3y plus 1 equals 12x minus 16. Now what form does it want my answer in? Ax plus by plus c equals 0. So I'll leave the 12x's there. I'll minus 3y from both sides. I'll subtract 1 from both sides, leaving with 0 there. So the equation of my line is 12x minus 3y minus 17 equals 0. And that is question 14 complete. Question 15. Okay, let's start with part A. I have to find the equation of the line which goes through point A and point B. Well, the gradient of that line is going to be 2 minus 6 over 12 minus 4, which is minus 4 over 8, which is minus 1/2. So the equation is going to be y minus, I'll use the point A, y minus 6 equals minus 1/2, multiplied by x minus 4, multiply everything by 2, 2y minus 12, multiply that bracket, minus x plus 4, and it wants it in the form ax plus by plus c equals 0. So I'll add x to both sides, and I'll subtract 4 from both sides. So there is the equation of the line L1. That's part A done. Right, part B. The straight line L2 passes through the origin. Okay, y-intercept is 0, has a gradient of minus 2/3. So in which case, the equation of that line is simply y equals minus 2/3 of x. So there's the equation of L2. The lines L1 and L2 intersect at the point C. Find the point C. Right, so I simply have to solve simultaneously L2, which I've got there, and L1, which I'll copy down here, x plus 2y minus 16 equals 0. Let's substitute in that value for y from L1 into, the value of y from L2 into my equation for L1. So I'm going to have x now plus twice minus 2/3. That's minus 4/3 of x equals 16. So minus 1/3 of x equals 16. So minus x would be 48. So x will be minus 48. If x is minus 48, y therefore will be minus 2/3 times minus 48. So y will be positive. 1/3 of 48 is 16, so 2/3 is 32. So my point C has coordinates minus 48, comma 32. That's where L1 and L2 intersect. Right, part D. Do that here. Show the lines OA and OC are perpendicular. Let's find the gradient of OA and the gradient of OC and see if one is the negative reciprocal of the other. The point A is 4, 6. So the gradient of OA is going to be the rise, 6 minus the y-coordinate of O, which of course is 0. 6 minus 0 over 4 minus 0. So that is just 1.5, or 3 over 2. Let's have a look at OC. Well, the point C is minus 48, 32. So I'm going to do the y-coordinate of C, subtract the y-coordinate of the origin. So that's just 32 over the y-coordinate, the x-coordinate of C minus the x-coordinate of the origin. So that's just minus 48 minus 0, or minus 48. Now, what can I divide? I can divide top and bottom by 16. Leaves me with 2 over minus 3, which of course is minus 2/3, which is the negative reciprocal of OA. So OC and OA are perpendicular. Good. Brilliant. Okay, that's D done. E, work out the lengths of OA and OC. Write your answers in the form K lots of root 13. Okay, let's have a look at that. So OAD, so I'm on part E now. OA, well that's just the length from the origin, and I've gone 4 along and 6 up. So that length, OA, is simply the square root of 6 squared plus 4 squared, which is the square root of 36 plus 16, which is the square root of 52, which is 2 root 13 is 52, is 4/13. Now let's have a look at OC. OC is minus 48 and then 32 up. So let me draw that here. Minus 38 and minus 32 and 48. Okay, so OC is the square root of 32 squared plus 48 squared. Let's have a look at that. 32 squared plus 48 squared is, so that's the square root of 3328. Now if I do square root answer equals, I get that that is 16 times root 13. So work out the lengths of OA and OC. Write your answer in the form K root 13. Done. And now I'm on part F. Work out the area of the triangle OAC. But the area is going to be OA multiplied by OC, base times height, divided by 2. So that is 32 times 13 over 2, which is simply 16 times 13. And 16 times 13 is 208. So that is my solution to question 15. Question 16. Use the distance formula to find the distance between these 2 points. Well, I think calling it the distance formula is slightly over the top, as it's only Pythagoras, but never mind. Here is the distance formula. The distance is the square root of the difference in the x-coordinates plus the difference in the y-coordinates, because it's simply a right angle triangle and we're simply finding its hypotenuse. Okay, so to do part A, I've got the points 4A, A, and minus 3A and 2A. So I'll take my second point to be x2. So to use the distance formula then, that's going to be the difference in the x-coordinates is going to be minus 3A minus 4A. That should be squared, I beg your pardon. Squared plus the difference in the y-coordinates, 2A minus A squared. Let's see what that gives me. That is going to be the square root of minus 7A squared plus A squared, which is the square root of, well, minus 7A squared. It's 49A squared plus A squared. That's going to give me the square root of 50A squared. Okay, so that's part A done. Right, hence find the distance between these pairs of points. Right, so I'm going to need to link these pairs of points to my general points. So my general points are 4AA and minus 3A, 2A. Right, let's have a look at part B then. Part B is the point 4,1 and minus 3, 2. Well, clearly in this case, A equals 1, so the distance is going to be the square root of 50 times 1 squared, which is the square root of 50. Let's have a look at part C. Part C. 2 points I'm looking at here are 12, 3. So it looks like A is going to be 3, and indeed A is going to be 3. Looking at the second point. So A is 3, so the distance is the square root of 50 times 9, which is 3 root 50, isn't it? Well, I suppose I could simplify that again. I could have simplified this one, couldn't I? That's 5 root 2. Okay, so this is going to be, take out a 5, it's going to be 15 root 2. Okay, and lastly, D. My 2 points in D are minus 20, minus 5. Looks like A is going to be minus 5 here. And indeed, looking at the second points, that is how it's going to work. So A is minus 5. So that's going to be, my D is going to be the square root of 50 multiplied by minus 5 squared, which is 25. So what can I take out of there? Well, I can take out the 5 straight away. So that's just 5 root 50. I can take out another 5. So that's 25 root 2. So those are all my distances between the following points suitably simplified, and I'm kind of wishing I'd simplified this third in the first place. That's 5 root 2A squared. Okay, I think that's question 16 sorted out. Okay, so in question 17, we've got the point minus 1, 5, the point A on my diagram, and we've got the point xy, which is any point on the line y equals 3x. So I've drawn the line y equals 3x there. The first thing we need to do is to write an equation in terms of x for the distance between xy and the point A, which is at minus 1, 5. Well, the point xy, we know that that lies on the line y equals 3x. So I'm just going to call that line, that point, x 3x, because we know that y equals 3x. Right, now I'll use my difference equation now to work out the distance from my point x 3y to the point A, which is minus 1, 5. So the distance is going to be the square root of the difference in the x-coordinates. X minus minus 1 is x plus 1 squared, plus the difference in my y-coordinates, 3x, take away 5 squared. Now I can simplify that, of course. So that's going to be the square root of, multiply out my x plus 1 squared, x squared plus 2x plus 1, and multiply out my 3x minus 5 squared, don't mess it up. 9x squared minus 30x plus 25. And now I can simplify that to give me the square root of 10x squared minus 28x plus 26. So there you go, there's an equation for the distance between xy and the point A. Right, part B. Find the coordinates of the 2 points B and C on the line y equals 3x, which are a distance of root 74 from minus 1, 5. So presumably my distance, which is this, will need to equal the square root of 74. So I need to solve this equation. Well, I'll square both sides. Gives me 10x squared minus 28x plus 26 equals 74. This is a quadratic equation. I'll set it equal to 0. 10x squared minus 28x, 26, subtract 74, gives me minus 48, equals 0. I need to factorize this, really. Well, I can pull out a common factor. Gives me 2 lots of 5x squared minus 14x minus 24. And now I can factorize that. 2 lots of, or factorize it further. It's going to factorize to 5x and x, of course. And now I know I'm going to have a plus and a minus. I know they have to multiply to minus 24, and I know I need minus 14x's. So a bit of fiddling gives me this answer. So my two solutions for x, these are the x coordinates of the points which are the correct distance from the point A, are minus 6 over 5, and the other coordinate for x, the other solution is 4. And then I can substitute those values of x into my equation y equals 3x to give me the y coordinates of each of those points. So my 2 points, which the question calls B and C, are the points 4, 12 and the point minus 6 fifths, so minus 1.2, and minus 18 fifths, which is minus 3.3. Let's plot those points here, just because it's going to help us in this question to keep track of what's going on. So this one can be the point B. I'll put it up here. It can be 4, 12, 4, 12. Here we are. There's the point B. Okay, that doesn't look like 412, but I think that's because I've got my 10 labelled where it should be 11. There we go, that's a bit better. 412, and the point minus 6 fifths and minus 18 fifths is going to be about here. So those 2 points are the required distance from A. So these 2 lines which I'm drawing now both got a length of root 74. Okay, nice isosceles triangle there. Right, part C. Find the equation of the line which is perpendicular to y equals 3x. Well, then I know its gradient is going to be minus a third, the negative reciprocal of 3, and it goes through the point minus 1, 5. Well, y minus y1 equals the gradient multiplied by x minus x1 minus minus 1 is plus 1. Multiply everything by 3. Multiply out this negative bracket. Okay, and what form shall I put that in? I'll write it as y equals, and have 3y equals minus x plus 14. So y equals minus x over 3 plus 14 over 3. Now that is the equation of which line? That is the equation of the line that goes through A, but is perpendicular to y equals 3x. So it's the equation of that line there. And in the question, it calls that line L1. So I'll label that L1. There we are. Okay. Part D. Find the coordinates of the point of intersection between L1 and y equals 3x. It's asking me to find the coordinates of that point there. Okay, well that's going to require me to solve y equals minus x over 3 plus 14 over 3 together simultaneously with y equals 3x. Y equals this, y equals that. 3x equals minus x over 3 plus 14 over 3, y equals that. Y equals this, y equals that, so this equals that, multiplied by 3. Okay, add x to both sides, divide by 10. So my x-coordinate of that point is 1.4, and I know the y-coordinate is 3x, so that's 4.2. So the coordinates of that point of intersection are 1.4, 4.2. And that is point D done. Right, we have to do part E now. Now, while this fills me with dread, what I'm going to do is I'm going to delete all my work for C and D to give me some space. So if you need to look at that again, you best pause the film. Right, here it goes. It's on its way out. Now, for part E, I need to find the area of a triangle. Now, clearly, to find the area of the triangle, I need to know its base and its height. And so in this case, I need to find the length of the line BC, and also, if I call that x there, the length of the line AX. That would give me the base and the height, wouldn't it? And then I could multiply those together and divide by 2. An alternative technique would be to find perhaps the length of AX and use that alongside your knowledge of AB to find the length of XB, double that, and then you've got the base. I'm going to do the former method here. So first of all, I'm going to find the length of BC, the length of the base of my triangle. Right, BC. Well, B is the point 412, and C is the point minus 6/5, minus 18/5. So I can find the length of BC by looking at the square root of, what's that going to be, 5.2 squared, plus I've got 12 and another 18/5, 15.6 squared, and square rooting that. When I do that on my calculator, I get 26 root 10 over 5. And I can find the length of AX, again, by looking at the coordinates of A. A is minus 1,5, and X, which is 1.4, 4.2. So if I think about those distances there, AX is going to be the square root of 2.4 squared plus 0.8 squared. Great. So AX, when I put that in my calculator, gives me 4 times root 10 over 5. So the area of my triangle now, I've got the base, which is BC, 26 root 10 over 5. I've got the height, which is 4 root 10 over 5. I'm going to multiply those together and halve their product, which gives me an answer of 20.8 for the area of triangle ABC.
Question 18. I have a line of best fit here, showing the relationship between oil production and carbon dioxide emissions. Part A. Use 2 points on the line to calculate its gradient. I'm going to choose 2 convenient-looking points. First of all, this one, which is just point 900,0, and secondly, this one here, which is the point 4,400, 35,000. So I'm going to work the gradient by doing the rise over the run. So my gradient will be the rise, 35,000, over run, 4,400 minus 900 is 3,500, giving me a gradient of 10. Part B. Formulate a linear model linking oil production, P, and carbon dioxide emissions, C, whereby carbon dioxide emissions is something multiplied by the oil production level plus a constant B. This is very similar to Y equals mx plus C. And the A will be my gradient. Now, how am I going to find the B? Well, I know that the point 900,
is on the line. So I know that when C equals 0, P equals 900. So I can simply solve that equation to find that B is equal to minus 9,000. So my linear model is that C equals 10 times the level of oil production minus 9,000. Okay. Interpret the value of A in your model. Well, A is the gradient, isn't it? It's the rate of change. It shows how a unit of P going up impacts on a unit of C. So, what it means is that as my unit of P goes up by 1 unit, well that's 1 million tons, so it means that if production increases by 1 unit, 1 million tons, then carbon dioxide emissions go up by 10 million tons. Okay, lastly, part D. With reference to your value of B, comment on the validity of the model for small references for small values of P. Well, the trouble is that if P is less than 9,000, then apparently I have a negative value of C. And that can't be feasible, can it? It can't be possible, for instance, just because production is less than 9,000, that I have got negative carbon emissions. And with specific reference to the value of B, I guess if oil production is 0, then according to the model, my carbon dioxide emissions is minus 9,000, which of course is not feasible. So that's question 18 done, and that is the end of the film.